Good morning to all. Today's topic is high-speed corridor engineering, the core concepts, handled by Dr. K. Pungudi, Professor, Department of Civil Engineering, Director, CCMM, CSR University, Varangal. What is high-speed corridor means? It is the dedicated rail transport path for high-speed travel. The speed is minimum of 250 km per hour with minimum disturbance. Nowadays, we are able to travel with average speed of 70 km per hour only. Even though we are able to say that 100 km per hour, but the average speed is not able to increase that 70-80 km per hour. Once the high-speed corridors are completed, then we are able to travel with minimum speed of 250 km per hour in land itself. The seven new highway speed railway corridors are Mumbai to Ahmedabad, Mumbai to Pune, Mumbai to Hyderabad, Hyderabad to Chennai, Hyderabad to Bangalore, Bangalore to Chennai, Delhi to Varanasi, Varanasi to Siliguri. So, with the announcement of the seven new high-speed rail corridors in the Union budget, the Modi government continues to reshape India's infrastructure by strengthening connectivity, reducing travel time, and supporting long-term economic growth aligned with the vision of Viksit Bharat. This massive high-speed rail network with seven new corridors announced in 2026 aiming for 300 plus km per hour speed to connect the major economic hubs like Mumbai, Ahmedabad, Delhi, Hyderabad, Chennai, Varanasi. The 508 km Mumbai Ahmedabad corridor is currently under construction with 7,000 km of network projected by 2039 to 2040. The high-speed corridors are Mumbai Ahmedabad MAHSR. This is the India's first under construction bullet train corridor covering 508 km with a 320 km design speed. Chennai Bangalore 343 km projected travel time of 1 hour 14 minutes linking two major industrial tech hubs. Bangalore Hyderabad 618 km with the expected to reduce the travel time around only 2 hours by strengthening the economic links. Chennai Hyderabad 705 km connecting these cities with the travel time of 2 hours 55 minutes. Mumbai Pune 160 km planned with an estimated only 48-minute travel. Uh, the time to reduce congestion in the western region. Pune Hyderabad 767 km providing high speed onboard connectivity to the southern part. Delhi Varanasi 797 km and Varanasi to Siliguri 700 km. These are the major corridors strengthening northern and eastern connectivity. The project highlights the targeted speed is the design speed is 300 to 350 km per hour, significantly faster than any other existing networks on land. The implementing agency is National High Speed Rail Corporation Limited, that is NHSRCL, which is handling the projects under the Ministry of Railways India. Long-term vision, the government aims for a 7,000 km HSR network by 2039 to 2040 with the long-term goal of 15,000 to 21,000 km longest runways. The infrastructure impact, these projects will support regional growth by connecting key industrial and technical clusters. The projects include advanced specialized tracks, signaling and stock separate from existing Indian railway infrastructure. So for this HSR, the tracks will be constructed newly. So the existing tracks are not at all suitable for the HSR. So new corridors are constructed. The constructions are undergoing. The importance of the high-speed corridors are that it reduces the travel time, boosts the Indian economy, enhances the connectivity between the important cities of India, increases the safety, comfort travel is assured. The global examples are we are following and adopting the foreign countries technologies. we are taking the Japan technology, that bullet train with high-speed train. France TGV technologies. It connects over 200 cities across France and neighboring European countries, making it a principle of European travel with both premium and low cost options. China is the high speed rail network. The HSR network include newly built rail lines with a design speed of 200 to 380 km per hour. Uh, this high speed rail is the technology from Chinese. Indian scenario, Mumbai Ahmedabad bullet train is under construction. The future corridors are also planned. The Mumbai Ahmedabad High-Speed Rail Corridor, that is MAHSR, is an under construction high-speed rail line which will connect Mumbai, Maharashtra, the financial hub of India, with Ahmedabad, the largest city in the state of Gujarat. When completed, it will be the India's first high-speed rail line with a design speed of 350 km per hour viaduct, which will be the longest bridge in the world. The line will use the Shinkansen technology from Japan, including rolling stock, signaling and design standard with technology transferred to support the Make in India program. The basics are route selection, demand analysis, and feasibility study. So before starting any project of railways or highways, we have to do the routine analysis. Start with the route selection. For that, we want to conduct a lot of surveys. Then, what is the demand? With that, only demand and supply should match. Then, what are the feasibility study to construct? So, this high-speed rail corridor planning focuses on connecting major economic hubs with dedicated, often elevated tracks designed for the more than 300 plus kilometer per hour speed. Key aspects include using advanced construction like full span launching method, standard gauge tracks, and integrating with existing transport for multimodal connectivity. In India, nowadays we are using broad gauge of 1676 mm, but here the bullet trains and the high speed rails, we are using the standard gauge tracks. The core planning components are route alignment and structure. The route alignment plays the important role, that is the first construction work. Typically, the dedicated grade separated tracks to ensure the safety and high speed. So this route alignment itself, we are taking the Japanese technologies for the complete alignment. Once the alignment is completed, then the remaining things are able to fix easily. Station strategy. It is designed as multimodal hubs, often featuring green building techniques like solar panels, rainwater harvesting, and integrated urban transports like metro, bus, and airports. Technology and speed. This is designed for the speed of over 300 km per hour, employing advanced signaling, train control systems, and specialized rolling stock. Construction techniques, already we saw about that. We are using the full span launching method instead of the incremental launching method for rapid construction. 10x faster construction is able to achieve when compared to the conventional segmental techniques. Sustainability and design. The elevated tracks and where possible, tunnels minimize the surface land acquisition and disturbance. Stations aims for the energy efficiency with the help of the solar panels. The project execution is usually implemented through special purpose vehicles like NHS or CL in India, which handle land acquisition, environmental clearances, and partnership management. The alignment and design, the straight alignment is always preferred with minimum curvature. Here, work on Hyderabad Mumbai high speed train gains. Uh, the final location survey is completed. It marks a major milestone for the MPS project. The highlights are a top speed up to 320 km per hour, Corridor length is 790 km. Estimated travel time is 4 to 6 hours only. Current train time is 12 to 14 hours. This 12 to 14 hours will reduce to 4 to 6 hours. So surely we are able to reduce the travel time and increase the comfort of the passengers. So we are able to save the time of each and every passengers of more than 50 percentage. And this is the faster interstate travel between the Telangana and Maharashtra, the reliable alternative to the air travel. It boosts the business trade and regional integration. It enhanced mobility for professional and frequent travelers. The proposed route is Hyderabad, Pune, Solapur, Mumbai, alignment designed to connect key urban and economic centers. The infrastructure is a dedicated high-speed elevated corridor that is totally new track from the existing ones. It designed exclusively for bullet train operations. Advanced safety and signaling systems are planned. Horizontal curves, large radius curves are implemented. Passenger comfort is the main important in this. The HSR utilizes large radius curves of 4,000 to 7,000 meter radius to minimize the necessary cant, that is nothing but super elevation, as high cant can lead to cant excess if trains are forced to slow down. Nowadays, the existing tracks we are using only 400-meter radius, that is the maximum curvature which are used at the curves, but for high speed rails this will be increased to 4,000 to 7,000 meter, so that we are able to ensure the comfort and the minimum super elevation. And what are the enhanced features and amenities in the Amrit Bharat trains? The entire train is under CCTV surveillance in all coaches, so that the passengers are able to travel with comfort, feel free, and there is no threat of any issues. Improved toilet designs, aerosol based fire suppression systems, Type A and Type C mobile charging sockets, emergency talks for passenger guide communications, easier ladder for upper berth climb. No need of any risk for the upper berth. Even the senior citizens are able to prefer the upper climb. Upper berth, since the ladder system will be like that. Improved crossworthy features and improved LED lights and charging sockets, jerk free semi automatic couplers, so that the vibrations will not affect the trains and the passengers. Uh, so that nowadays some semi automatic couplers also used to reduce the vibrations. And the vertical alignment, gentle gradients are used, smooth transitions curves are used to connect the circular curve and the straight, so that we are able to cross the curve gently and the direction is changed with comfort travel. Hyderabad Chennai bullet train project advances as railways submit final alignment to be included in DPR, that is the detailed project report. Land acquisition and the challenges and the social impact and cost considerations. Here, we have to identify straight paths that avoid heavily built up areas is the very high challenging. While the Mumbai Ahmedabad bullet train has achieved nearly 100% land acquisition, new corridors like Mumbai Hyderabad, Pune Hyderabad, and others face will face the similar challenges. Social impact, the displacement of families and loss of livelihood for farmers causes local unrest and requires lengthy negotiation process. R&R, it is a repair and rehabilitation, shifting of communities and assets and tribal areas requires at times navigating complex professional or agricultural land regulations. So in the land acquisition, these are the issues. But anyway, the government is able to compromise the public, and the public one day they will ready to accept the project, and land acquisition is not at all an issue, but it will take some time. The types of tracks are ballasted track and ballastless track. Ballastless tracks or slab track is the modern railway track system where the traditional loose ballast and sleepers are replaced with a rigid concrete or asphalt base, providing higher stability, lower maintenance, and increased durability for high-speed trains and metro lines. This structure ensures consistent track geometry, making it ideal for tunnels and bridges. What are the advantages means? The maintenance cost will be very less, extremely long service life with minimal maintenance needed. Since nowadays we are using ballasted track, this ballasted track, the entire durability is 50 to 60 years only. But with the help of the ballastless track or slab track system, the durability of the structure will be increased to more than 70 years. So automatically we are aiming towards the sustainability. High speed, ideal for the high speed trains due to stability. The durability, there is no settlement of ballast, providing a rigid and precise alignment. Safety, better performance against the derailment consequences. So that the ballastless track is nowadays famous. And for especially high speed railways, we are using the ballastless track instead of the ballasted track. This is the ballasted track here, ballast with 1 is 1.5 is to 1, that slope it is maintained. Here the slope always to be maintained, and this ballast should be always compacted, and the honeycombs to be avoided. For that special maintenance team always to be at the track to maintain all these things. But here this is the ballastless track or slab track. Here, when compared with these two tracks, here the initial cost for this ballastless track is more, but the maintenance and the durability, maintenance is less, durability is more. But here the initial cost is less, but maintenance cost, operating cost is much more when compared with the durability. So here nowadays, whatever may be the new tracks, it may be of ballastless track or slab track. So we have to construct first a slab, then on the slab, the rails to be fixed. Rails and this rails are automatically connected on slabs, and the sleepers are uh, combinedly with the slabs. So slabs and the uh, uh, sleepers will combine together. There is here see that this is ballast and this is the sleeper. But here it is the two-in-one technologies. Ballast and the sleepers are combined together in the slab system. And the rail types which are used in the high-speed rail corridors, we are preferring the continuous welded rails and the high-strength steel rails. Already we are using only flat-footed rails. In that there is no change, but the connection between the rails now it is initially we are using the joints, but nowadays we are going for the continuous welded rails. It is a railway track system where steel rails are welded together into long seamless strings, often hundreds of meters or even in kilometers long, rather than being bolted together at joints. This CWR, that is continuous welded rails, eliminates joint related maintenance, enhances stability, allows high speed, and provides a smoother ride. And come to the composition of the rail, we are going for the micro alloy rails. Rails utilizing small additions of vanadium or niobium to enhance the tensile strength without compromising the ductility or weldability. So Here, with the help of the micro alloyed rails, we are able to increase the tensile strength of the rail is 1400 Newton per mm square. Up to now, we are not able to achieve 800 Newton per mm square up to that limit only. But with the help of the micro alloyed rails, we are able to go up to 1400 Newton per mm square, so that the elasticity of the rails is increases. Sleepers. Mostly sleepers also included in this slab. Suppose we want to go for the separate sleeper system means then the preferable sleeper is pre-stressed concrete sleeper. They are the advanced sleepers when compared with any other sleepers like wooden, steel or composite sleeper, and the durability is high, and the life of the pre-stressed concrete sleepers is more than 50 to 60 years. And track stability. The track is resistance against the vibration. Precise alignment is following, and for this we are following the Japanese technologies. So there is no change in the alignment at any time. Bridges, long span bridges are used in the HSR. Aerodynamic design is taken from the France. Tunnels used in hilly train. Pressure control is always that technology is used at the tunnels. India is actively developing specialized tunnels for its high-speed rails network, most notably for the 508-kilometer Mumbai-Ahmedabad high-speed rail corridor. This project features India's first undersea tunnel and extensive mountain tunneling to support trains traveling at 320 km per hour, aiming for completion in phases. Key tunnels in high-speed corridors. A 7-kilometer tunnel under the Thane Creek with 1.8 kilometer located under the sea is being constructed as part of the bullet train project. NATM tunnels, several tunnels on the Mumbai-Ahmedabad high-speed rail route are being built using the new Austrian tunneling method, including a 5-kilometer lengthy tunnel, and the mountain tunnels. Multiple tunnels are being constructed through the Western Ghats for the bullet train corridor. Viaducts. Viaducts are nothing but a long, high bridge which carries a railway or road across the valley. So here elevated structures are needed, and it reduces the land use. Key developments in the HSR viaducts. Mumbai Ahmedabad corridor over 300 km of elevated viaducts are completed. The construction techniques, already we saw that full span launching technology method for 257.4 km span by span, that is SBS method is used for 37.8 km. The longest bridge is the 2.3 kilometer lengthy bridge over the uh, Baidarna river is part of the Mumbai Ahmedabad high speed railway project. The Mumbai Ahmedabad high speed rail project has achieved a major milestone with 300 km of viaduct construction completed, featuring indigenous engineering and Japanese partnership. This milestone includes 257.4 km built via full span launching method. And here, Mumbai Ahmedabad bullet train transport, the features are 12 stations, the totally. Among the 12 stations, 8 stations are at Gujarat and remaining 4 stations located at Maharashtra. And operation speed is average operation speed is 320 km per hour. And if they are using only limited stop, then the travel time is 2 hours 7 minutes only. But all stops, if the train want to stop at the time also, the travel time will not be more than 3 hours. And here the total length of a 508 kilometer at Gujarat, the length is 348 kilometer, DNH 4 kilometer. Then that is Dadra and Nagarveli Union Territory 4 kilometer we are touching. Then Maharashtra 156 kilometer. Then viaduct of 465-kilometer length is there, and bridges 28 steel bridges are there, and 25 river bridges also there in that route. Earth structure 7-kilometer earth structure is there, and tunnel undersea 7 kilometer, and the total tunnel is 21 kilometer length. Mountain tunnels 8 numbers are there, and J slab tracking slab system is used here. These are the main features of that MAHSR route. Speed under the track. Maximum speed is 350 km per hour. Operational speed is 320 km per hour. Average speed is 250 km, and the gauge is standard gauge of 1435 mm only. Nowadays, we are using 1676 mm broad gauge, but at high speed rail corridors, we are using the standard gauge only, and the gauge is 1435 mm only. Kindly note this. Then tracks 2 by 25 kilowatt AC overhead catenary is used. Signaling communication based train control system, that is CBTC, is used for the signaling. Safety, even during earthquake, urgent earthquake detection and alarm systems are available for automatic braking in case of an earthquake, so that during earthquake the train will automatically stop, and each one is easily able to escape from the earthquake if happened. Then power supply, 12 tracks and substations with two departments, the power supply will be maintained. Funding and financial structure of bullet train project. The Mumbai Ahmedabad High-Speed Rail Corridor project has an estimated cost of Indian rupees 1,08,000 crore excluding taxes. The project is being implemented with financial support through an official development assistance loan from the Japan International Cooperation Agency. Approximately 81% of the total project cost will be financed by the government of Japan, while the remaining cost will be bared by the government of India. India's first undersea tunnel, the Mumbai Ahmedabad High Speed Rail Corridor features a 21-kilometer long tunnel, out of which 7 kilometers will run under the Thane Creek, making it India's first undersea rail tunnel. The tunnel will be built using a combination of tunneling methods, and 5 kilometers through the new Austrian tunneling method, and the remaining 16 kilometers with tunnel boring machines for the faster mechanized excavation. Mountain tunnel for the project. The MAHSR corridor features a total of 8 mountain tunnels. 7 of these tunnels are situated in the Balgar district of Maharashtra, while the remaining one is in the Valsad district of Gujarat. The tunnels will be constructed using the NATM, that is the Austrian tunneling method. Steel bridges, a total 28 steel bridges are planned along the Mumbai-Ahmedabad bullet train corridor, with 11 located in Maharashtra and 17 in Gujarat. For more details, kindly go through the website of Metro Rail News, Mumbai-Ahmedabad High-Speed Rail. And the platform design is totally different. Here level boarding is used, so that it is very comfortable for the passengers and easy accessibility for the loading and unloading of the goods also. And the electrification system, overhead catenary system is following. Power supply, high voltage systems are there, and the reliable grid connections are ensured. Traction types, electrification traction is preferred. Energy efficiency, regenerative braking system is adopted in this MAHSR system. Disaster management, emergency response systems are there, and once the construction is over, then the government will give the emergency response awareness to the public, and the entire route is fenced, and intrusion detection also, that methods also there, so that we are able to easily avoid the accidents of animals and also the human beings. And aerodynamics and comfort, this aerodynamic technology is adopted from the France, so that the drag is reduced and we are able to feel comfort, and the vibrations also very less. Noise control, sound barriers are used to control the noise. Passenger comfort, smooth ride is ensured because of the reduction in the vibration. Environmental impact, the reduction in emissions is ensured, so that environmental impact is very less. Eco-friendly construction materials are used so that we are able to achieve the sustainability also. Here, noise and vibrations are under control, so we can able to say that these high-speed corridors are green corridors. Cost factors, the construction cost and the maintenance cost. Anyway, we are implementing these projects with the foreign support, since each project in terms of lakhs and crores are we are lakhs of crores we are using, so that by considering all the economical aspects, this cost can be borne by the government. Future trends, hyperloop concepts are is the future trends in the HSR. Hyperloop construction is under testing at IIT Chennai. Once Hyperloop technologies are able to implement, then that may be the another generation technologies than the HSR system, so that we are able to adopt the smart transportation system on land itself. Very soon, all are able to travel and enjoy the HSR throughout India. Thank you. Thank you for watching.